So welcome to my Windows Server 2012 R2 top 10.2 features. And a real key thing about Windows Server 2012 R2 is that it is only been 1 year since the previous version. So we don't really have the same huge amount of changes over all these different functional areas. Instead, what Microsoft have done is, instead of making lots of small changes across everything, which is one option, they really seem to have focused on a few key scenarios and made very, very deep investments in those areas, those particular scenarios, most of which are cloud focused. So we see a lot of improvements, obviously, around Hyper-V, around the storage, around management. And there's some of the things I want to drill down into in this sort of top 10. Now, there were lots of things I'm not going to talk about that didn't make the top 10. Doesn't mean they're not great features. It doesn't mean this top 10 is the right top 10. It's just, for me, what I think are some of the coolest things. Improvements in IP address management, IPAM. It's got much, much better integration with VMM now. NIC teaming was really changed to have much, much more granular breaking of traffic by using these flowlet concept. So I actually get better balancing of traffic across my NIC teams. A new type of NIC teaming using a dynamic mode, which really takes the best of the Hyper-V port and the old hash values that we had in the past. So lots and lots of different features, but I'm going to focus on what I think are sort of the biggest 10. Now, something that's not a new R2 feature is Server Core. So this really undergone a big change in Windows Server 2012. The whole idea is we want to minimize sort of the patching overhead on maintenance of our operating system. And so Server Core was originally introduced in Windows Server 2008, and it's a choice you had to make when you installed the operating system. And really it missed out a lot of the graphical tools, the management tools. So it was a much smaller footprint operating system. There was less to patch, less attack surface, etc. But because you had to make this choice when you installed the operating system, it actually wasn't that popular. It was only in Windows Server 2012 that actually made Server Core now something optional and easy to get to. And this was done through the introduction of configuration levels. So I can take a server, I can install it as serve with a GUI, what used to be called full install, and I could remove, for example, just the management tools and the graphical interface. Or I could say, well, just remove the graphical interface, but leave the management tools. Or I could say remove everything and leave me with a Server Core. And I could add and remove these different layers really at any time, just requiring a reboot. And you always want to use Server Core if you can. And some of the big changes in R2 is every single role is now supported on Server Core, really with the exception of fax. I'm not sure if fax is widely used anymore for Windows Server 2012 R2 servers, but we still can't run fax on Server Core. And obviously, if I'm a remote desktop session host, I probably don't want to give my users a Server Core interface. That's not very useful. But to all intents and purposes now, everything in the operating system I can actually go ahead and run on Server Core now. Additionally, Server Core actually shrunk. And they've actually done some clever stuff on Server Core. Basically now, all of the things that aren't being used, components that aren't actively being used when I do servicing, it actually now compressed, so it gets even smaller. So for example, if I jump over to a box over here, I actually have a Server Core box that's up and running. And if I go ahead and look at my disk footprint for this virtual machine, it's going to be about 5 gigs. So I took the page file out, so it's 5 gigabytes. So that's a normal server in Core. I've not removed anything from disk. That's just a standard deployment now. So if everything ready could be used, but it's using some compression to minimize the amount of space it's actually taken up. So it's actually gone and shrunk. Additionally now, if you want to get a gold certification level for your custom app, it has to run as either Server Core or MinShell. So MinShell is where you have the management tools installed, but still not the graphical interface. So still don't have Explorer or Internet Explorer, any of those things. I kind of talked about the reduced footprint already. So it's basically 1 gigabyte smaller than the 2012 version because of this compression that's now used for features you're not installing or that have been superseded by updates. So Server Core is still number one. You want to be using Server Core everywhere you can, especially on Hyper-V hosts. I want to minimize any time I have to reboot that box and the amount of managing required. Number 2 is PowerShell. And what we actually get now is we get PowerShell v4. And PowerShell v4, the big change is really desired configuration management. And this completes the initial vision of Monad when it was first kind of created. The idea here is that I can say, hey, this is how I want a server to look. I want these roles installed. I want these files in this place. And it's going to help keep it looking that way. So today you might use Configuration Manager, for example. Well, now I can do it with PowerShell. And if you think just beyond what's new in v4, I mean, v3 added workflows. I mean, it had these great other capabilities, simplified logic. But really, PowerShell is the management approach for Microsoft. I mean, if you think server, if you think System Center, Exchange, SQL, many hardware partners, application partners, they're giving you PowerShell modules. Even competitors. You look at things like VMware and their Power CLI. They're giving you PowerShell. So if you're going to learn one thing to really simplify your management, it's going to be PowerShell. Now, actually, I just wanted to jump over quickly. And let's look at a server. Just get some idea of what this sort of PowerShell, this desired configuration management does. Now, the idea is you have this new configuration. And now I'm doing it for this particular server. And you create resource blocks. And these are basically things and resources you want to configure, the ways you want it to look. So, for example, I could say a Windows feature. So I want to make sure it's present, but you could say absent. And I want to make sure the web server role is there. Now, I've commented that out. What I'm using is I want to make sure a certain directory structure is present all the time. And it's going to go through the subdirectories as well. So I'm saying I want this destination path that I'm specifying to always look the same as this source. Maybe this source is on a network share somewhere, it's a central version. And I want to make sure all my servers always have the same content. So basically what I go and do is I create this configuration. And you can also change the way this desired configuration management actually works. Does it apply and autocorrect, which is kind of the default, how often it should refresh. But I'm not going to do that. What I'm doing is I've created this my test file config you saw me just run. So I'm going to execute that. And what it does is it actually goes and creates a file, this moth file, that now contains this particular configuration. So my next step is to actually go and apply it. Now what I'm going to do is I'm just going to run this with the dash wait. So it's going to make it actually run interactively. Before I do that, if I actually jump over to the folder we're dealing with, I have my source folder. It's got one file in it. And I could go and create other files, create another test2, whatever. And then I have my target folder, which is what I want it to look like. And I could go ahead and create another folder, test3, and I'll stick that in the source. So this could be on that central share, whatever I want. I want it to look this way. And then I'm just going to trigger it to invoke that job. And if I go to my target, you see I have exactly the same content. And if you take out the wait, so it wasn't interactive, this would just run kind of in the background. And it would periodically check and fix it depending on what my configuration was. So if I actually go and look at what my config says, my default says, well, run every 30 minutes, and it should apply and correct anything that's wrong. So that's what I would actually go and get in my environment. So I've refreshed frequency checking every 15 minutes. So just going to go and make things look the way I have per this configuration. Now this is kind of the V1 of desired configuration management. And right now there are 12 different of these kinds of resource blocks available. And these are what they are. So they're all documented here. And I can see there's logs, there's packages, process, registry, roles, which you saw how to use the script. But this is the V1. Think back to PowerShell V1, and there were really only a few commandlets, and now there's thousands. This is going to be the same. Yes, there's a small number right now that I can use with desired configuration management, but this is just going to get bigger and bigger. You can go and create your own, Microsoft are going to start blogging and actually release more of these available to you. But this is a huge feature. The ability to now say, hey, I want a server to look this way, and PowerShell will just keep it looking that way, or I can update some central config and then apply it to all these servers. This is a huge shift in how we think about managing our boxes. So this is definitely a piece of functionality if you're not using, you want to get to understand and start leveraging in your environment. So that's PowerShell. Number 3 is storage innovation. Now, I did a Windows Server 2012 version of this top 10, and storage was one of my items there. I mean, they did a huge amount of functionality. I mean, SMB3, which really made SMB an enterprise-level file-based protocol. I could use it for Hyper-V, for SQL, and I added a lot of functionality to enable sort of transparent failover between nodes in a cluster. Multi-channel for resiliency against single point of failures, receive-side scaling, use of RDMA, remote direct memory access capable network cards through SMB Direct. And really these things have just been built on in 2012 R2. For example, small block I/O. That was an area that really wasn't tuned that great in Windows Server 2012, and you can really see sort of 50% improvements now in performance for those small I/Os, those sort of 8K I/Os using 2012 R2. So for virtualization, when you have lots of these random writes and I/Os going on, you're going to get much, much better performance. Data deduplication, great feature in Windows Server 2012, was not supported for files that were exclusively locked. They are now. So I can now take my virtual environment, my Hyper-V environment, and I can dedupe my VHD, my VHDX files. Now, for Windows Server 2012 R2, the workload that has been supported, kind of tested and is approved, is VDI environments, where I have lots and lots of virtual machines running basically the same client OS image. They are supported to be deduped. Other workloads are not blocked. This doesn't mean it wouldn't work with other workloads, but it's not supported, it's not tested by Microsoft. Now, I've done some testing. I mean, things work great for all sort of workloads, but you do have to consider, think of a SQL database. Would I really want to be deduping a SQL database? Probably not. And so just because it's not blocked for other workloads, doesn't mean you want to use it for every workload. So supported is VDI only. There are probably other workloads that you're going to get great benefit by deduping those, but really you have to think about what's going on in those workloads. Do they support being deduped anyway? What could the possible impact be of deduping them? And there was improved repair and resiliency. The iSCSI target that's now in box is now VHDX based. So in Windows Server 2012, it used VHD, which means I had that same kind of 2 terabyte limit. It was only a fixed size I pre-allocated up front. The 2012 i2 iSCSI target actually now lets me use VHDX. So I can use differencing, I can use dynamic types disk, I can use fixed, and I can resize them once they're created. So it gives me a lot more flexibility from a storage perspective. And this time I've actually broken storage spaces out into their own area. So this is what I had in Windows Server 2012. The ability to take lots of different disks, stick them in a pool, and then basically create these virtual disks. They're not VHD or VHDXs, the naming is unfortunate. But create these disks that use those underlying storage. And I could do thin provisioning, I could do mirroring, I could do parity. And that's got better. I can do 3-way mirroring, I can do dual parity. But the real big change in 2012 R2 is it now has this concept of understanding solid state drives. So I have hard disk drives, HDDs, and solid state drive, SSDs. And I can mix them together in a pool. And that gives me a couple of really cool features. So firstly, I can now do tiering. So when I create a virtual disk, I can now say, well, hey, I want this much fixed and this much SSD. And it's going to constantly look at what's going on. And the hottest blocks, the ones that are used the most, it's actually going to go and move to the SSD tier. So I get much, much better performance. So this is huge. Most of my storage could be on the hard disk drives. But those most used blocks, they're going to get moved to SSD to give me a huge ramp in my performance. So let's just quickly walk through kind of like a test to do this. So I have a server here. If I look at my file and storage, I basically have 4 disks on this system. I have 2 hard disk drives and 2 SSDs. And obviously the boot drives, but I can't use those. So I've got 2 regular and 2 SSDs. Now from PowerShell, I'm going to go and create all this through PowerShell. So as you scroll down this underneath my commands. So the first thing, let's have a look at every disk I have that I could possibly use for pooling. So you can see they've got those 4 of them. And it knows which ones are hard disk drives and which ones are SSDs. I'm going to stick all of those into a variable. I'm going to create a new storage pool using all of those drives. So I'm going to call it my storage pool. So it's now going ahead and created that. And I can now see all the disks in that new storage pool. So it knows 2 of them are HDDs, 2 of them are SSDs. Now what I'm now going to do is I'm actually going to create 2 tiers. An SSD tier consisting of the media type of SSD disks. And I'm going to create a hard disk drive tier with all the disks that are hard disk drives. So I now have 2 separate tiers. And what I'm now going to do is I'm going to create a new virtual disk using those tiers, using 50 gig of SSD, 300 gig of hard disk drive. Now I'm going to create this as type mirroring, which means that I have to have at least 2 disks in each of the tiers because it has to maintain whatever resiliency I want, no matter which tier I'm using. So because I'm doing mirroring, I have to have 2 disks in SSD and 2 disks in regular. And then basically it's just going ahead and creating a disk, bringing it online if it was offline. And then I'm going to assign it a drive letter and format it. So just let that run for a second. Cancel that because it's going to format it itself. So now what I should see is I should have a new letter, M, which is that storage space. And if I actually go and refreshed inside and go and look at storage pools, once it's actually done this refresh, I'll see, hey, I have this new storage space and I'm using those 4 disks in it. And it just takes it a little while to catch up. There we go. So we're just going to go and scan. And you can see those 4 disks. I have that mirrored tiered space. Now what I want to do now is go ahead and create a file. I'm going to create a 5 gig file. And I'm going to kind of lie and pretend that 5 gig file is full. So I'm telling it, hey, set all the data to the end. So I now have a 5 gig file. Now what I actually want to do is I'm going to spin up. This is a SQL testing utility. And it basically, it's called SQL.io, but it really isn't anything specific to SQL. So I'm going to go spin up a command prompt, paste that in. And what it's going to do is just going to start hitting that drive for 3 minutes. Now before I do that, so before I run this command to trigger that, I just actually want to set up monitoring of my IOPS. So we go to logical disk transfers per second for the M drive. And kick that off and start this. And I see IOPS around sort of 500-600, which is what I'd expect from hard disk drives. Now what I'm going to do now is I'm actually going to say, look, I want to pin that file to the SSD tier, and that won't do anything. What I'm basically doing is I'm saying I want this file to always be in that tier. Normally over time, Windows would see what's going on and say, hey, I should move these bits. Now I'm going to force it to actually always put this whole file in the SSD tier. And I'm going to kick off an optimize, which says we'll go and check now. And it's going to see I said that file should be pinned, so it's going to go and pin it in right away. So what it's now doing is moving that file into the SSD tier. So this is kind of emulating it looking over time at the most popular blocks and starting to move those to the SSD tier. So it actually took a bit longer than I thought it was going to take. So basically my SQL, my 3 minutes timed out. But what I'm going to do now is I've got that same thing ready to run. I'm just going to kick it off again so we can see the optimize actually finished, that job completed, which means that file now should be sitting in the SSD tier. So if I kick off exactly the same performance check again, let me just start the scan, I should now see it be significantly faster. And you can see it's ramped right up there. And actually can't even see what it is. So it's now running at 20,000. So it's gone from sort of 500-600 IOPS to 20,000 IOPS because that whole file has now been moved into the SSD tier. And that's what you could kind of expect. If you have files and loads that are really heavily used, what this tiering is going to do by default at 1 a.m. each evening, it's going to go and look at what are those hottest blocks and actually go and move those into the SSD tier for you. So yes, you can manually pin files if you need to a particular tier. So I just did that to emulate so we didn't have to sit there and work out what the hottest blocks were. But typically all you're going to do is just let that run. It's going to see what the best blocks to sit in the SSD tier and it's going to move them for you. And you can see, obviously I'm going to get phenomenal performance for that data in the SSD tier. But for those not most used blocks, they're still going to sit in the HDD. They obviously wouldn't get you as high a performance. But overall, the most used data is going to be in the best place. So you're going to get the best overall hike in the performance available to you. So I'm just going to cancel that. Now, there's another feature called Write Back Cache. If I jump to the slide for a second. Write Back Cache actually says, well, the tiering is great for overall the most used blocks get moved to the SSD tier. But you'll actually notice when I created in PowerShell that new virtual disk, one of the things I actually said was to create a 1 gig write cache. And that actually is going to use the SSD tier as well. And what that says is, well, look, when I have some big write load, I'm initially going to write it into this write cache and then lazily write it out to the hard disk drive, which means if I have sort of these big bursts of write to this virtual disk, it's not going to impact anything else going on because initially it's going to write it all into that SSD and then lazily write it out to the hard disk drives over time when it can without impacting performance. And I actually had to fudge this demo a little bit. So one of the things you didn't see when I was doing this, the first time I created this file and I went ahead and ran the test, it gave me that 20,000 IOPS because what it had done by default, it was all sitting in the write cache still. So I actually had to go and force it out of the write cache and actually put it in the hard disk tier to make you see the normal performance, which I could then move it back into the SSD tier so you could see the difference. But this write cache is very useful as well when you do get those bursts of write to your storage spaces so you get the highest performance. So a lot of really cool stuff in there. And by default, you always get a write cache. So as long as there's enough space, I think by default, you're always going to get a 1 gigabit write cache for any virtual disk you create if there are SSDs available. And you have enough disks in the SSD to match whatever parity or mirroring you requested when you created the virtual disk. So number 5 is network virtualization. Now this is a feature in Windows Server 2012, but it really got a big boost in 2012 R2 for one big reason. So network virtualization is fantastic. It lets me basically abstract virtual machines from the underlying physical fabric. So I can have a red network, a blue network, anything I want. And they can use their own IP schemes. They could overlap. And I actually have that in one of my demo environments. So I actually got these started right now. That's why they all stopped. But I have a bunch of virtual machines. I'll power those on. And what I actually did is in my VM networks, I created a blue and a red network. And what we'll actually see is, notice my blue subnet 1 is 192.168.10.0. So is my red network, 192.168.10.0. You can completely overlap. They can have the same IP addresses. It doesn't matter. They're completely isolated from each other. They know nothing about the underlying network fabric. They don't know what IP scheme it uses. Completely isolated, which is fantastic. But one of the things we were missing when Windows Server 2012 was a gateway. If I wanted to be able to connect a virtual network to my physical network, if I wanted to connect to the internet, If I wanted to do a site-to-site configuration, I could not do that using inbox functionality. I would have to use a third-party HNV, Hyper-V Network Virtualization Gateway. Well, now there's an inbox one. So Windows Server 2012 R2 actually uses partly routing remote access services and partly just the networking and routing capabilities of Windows Server 2012 R2 to offer you a gateway inbox. Now you need to use VMM. While technically I guess you could use PowerShell to do a lot of this stuff, realistically you need to use VMM. And what you can actually see is I have a gateway. If I look at my fabric, I actually went ahead and I created a network service. And this is my Hyper-V Network Virtualization Gateway. And that's actually allowing me to go ahead and connect different virtual networks to the physical network, to the internet. I could do site-to-site configurations. So when I go back and look at, let's say, my blue virtual network, what you'll see is I've actually now configured it for connectivity to say, yes, I want to connect to an additional logical network. I want you to use NAT. So the inbox can do forwarding, which means it's going to keep the existing IP. It can use network address translation, which is what I need in my case because the IP scheme used by the virtual networks is not routable on my normal network. So it's going to use NAT. So it's going to convert those addresses to something that can just work on the regular network. And it can do site to site. So I actually connected this. And what that means is those virtual networks can now go and talk to the internet. So it's just giving me that bridge from my virtual network with its own IP scheme that in this case wouldn't normally be routable or access anything outside the virtual network, that it can actually go ahead and contact, for example, the internet. And so really that's why 2012 R2 network virtualization really is now a realistic technology because of that inbox gateway. But you do need VMM. Actually trying to manage this without VMM pretty much would be impossible. So remote desktop services, again, huge improvements in 2012. Really the big shift in 2012 R2 was there were some additional capabilities added. I talked about the dedupe support for VDI already. Session shadowing was kind of brought back. So if I go to my RDS server, and I'll fire up Server Manager. Remember, it's all managed through Server Manager. All my remote desktop services, I can go and click. And it's going to go and scan. It's going to let me configure it, create VDI collections, create publish applications, all through Server Manager. This will actually fill in. So while this is completing, I'm going to go and trigger off a user session. So I'm going to go and connect to this RDS session just as a regular domain user. So it's on that same RDS server and it's just connected. This is a user experience using just RDSH. And they could go and, I don't know, they go and look at all the applications. Maybe they're going to run Paint and just start doing stuff. Meanwhile, my RDS server, so it's painted out, it knows all the servers involved, and I can see, once I do a quick refresh here, I'll see I have that user Bruce. So the great thing I can now do is I can shadow. And I can say I want to view or control, prompt the user. So if I jump back to that user session, hey, someone wants to monitor, sure, go ahead, and I can control this with group policy. So now what happens, notice I have this little window with a complete view of what that user's seeing. So as the user, I go and make additional changes. I'm just going to go and see that in that window. So I've now got this nice sort of shadowing capability just built in. Quick reconnect. So what this allows me, if I got disconnected from RDP in the past, it could take a long time to reconnect. Now it's a much, much faster reconnect experience. If I change my displays, it's going to dynamically change my RDP connection. But one of the big changes, and this is really partly by acquisition of technologies, Microsoft are now actually providing RDP clients for iOS, Android, and Mac. So this is the versioning for iOS in the iTunes Store. This is the Android version in the Google Store, and then the Mac version. So they're now just available. So this really opens up RDP to a lot of other devices that in the past I would require a third-party RDP client for, or whatever protocol someone else uses like Citrix ICA HDX. And Microsoft have confirmed there will be a Windows Phone version coming out as well. And this really gives me a lot of capability from those other types of device. So this is an iOS device, and you can see I've installed the RDP client from the Apple Store. So I'm going to click that. And basically this is going to give me a very similar capability to what I can do from any other client. And one of the nice things this does actually support is I can actually type in the URL of a server. So you notice that it's actually this web feed. So I can go ahead and type in my own server. So I've typed in the feed, then I put in my credentials. So all that information's in, hit save. Now it's going looking, and look what it's done. It's actually gone and connected to that publishing. It knows all the applications that I published through there, and it's just made them available as published applications. And that's it. So a very, very simple, rich experience. If I actually jump back to my RDS server for a second, let me close that as well. You can see all those applications I just see on that iOS device are all the ones I'm publishing. So just by typing the URL, I actually now have access to all of them. They're just published automatically. And I select one. Doesn't match, that's fine. Connect always. See, it's creating the session, and now it's just going to open up the web browser. Something probably you don't see every day is running Internet Explorer on an iOS device. And that's it. So that's just one example. But that's how easy it is to publish those applications. And I'll be very, very honest. This is the first time I've played around with this. So we'll disconnect from that. I could go and run Server Manager. So because I should close that down. I can go and manage my servers from an iOS device. So it's just publishing the applications to that iOS device. And again, the same experience on Android, on a Macintosh, obviously on Windows, this works great. But it's really this ability to just quickly see all the published applications through any of those devices that makes this a really fantastic experience. So it just makes it more open and available. So work folders and workplace join. These are two really amazing technologies when you think of bring your own devices. So work folders enables me to take a single folder, personal folder for a user, and make it available to those non-corporate join devices. Windows 8.1, Windows 8.1 RT, Windows 7, and it's going to be there for iOS as well. And so let's just take what the end user experience is. So this is on a Windows 8.1. This will be exactly the same for 8.1 RT. It's going to be the same for Windows 7, the same for iOS. So I've work folders. And right now it's not configured. So I'm going to say set up work folders. All it wants is what is my work email address. It's then going to prompt me for what are my work credentials. It's going to say, where do you want to sync? So what work folders is going to do is going to sync a local copy. Now you cannot have more than one folder synced. You cannot sync a shared folder. Think of it as a single folder and its subfolders on a per user basis. It can apply some basic policies. And now what I'm going to see is my work folders, and all the content of that is going to synchronize between these machines. So even on a non-corporate asset, even when I'm not connected to the network, I'm still going to have access to my data, my personal data. Now, this doesn't mean you shouldn't use SkyDrive Pro, or if it's a corporate asset, you can use offline files. Definitely use that stuff. This is for when those technologies don't apply, they're not a good fit. Then I can go ahead and use work folders. And it's literally that easy to set up. So it's saying a problem occurred, sync it even over metered connections. It's not in the proper format. Don't know what that is. I've been playing around with this a lot lately. But I mean, literally that's done. I mean, I think it's still synchronized. Yeah, it's still synchronized the content. So it's basically saying I've done something else at some point. But it enables me to synchronize between certain devices. And it's very easy to stop this as well. So I go back to my work folders. And I can say stop using it. And then it will delete the content from my device. So it's now it's actually removed it from this device. So work folders gives me access to a single folder and its subfolders on really non-corporate assets. Workplace join enables those non-corporate assets to be a known device and actually use that as part of access to corporate resources. And again, that's going to be a Windows 8.1, Windows 7, iOS. And again, if I jump back over, so let's just show you an experience of something. So I have a claims application. I can connect to it. I have to type in my credentials. And it shows me all the claims. It's talking to ADFS. All the things known about me. And if I close it and go to it again, it's going to prompt me for my credentials again. Now what I'm now going to do to this device is I'm going to workplace join it. So I go change PC settings, network, workplace. Again, I just type in my email address. Now before I do that, let's jump over to my domain controller. And I'm going to look at my Active Directory. And I've registered devices. There's none there currently. Back to that device. Oh, wrong one. I'm going to join. It's going to want my credentials again. And now it becomes a workplace join device. What that means is, so firstly, in Active Directory, I now actually see this device has an object, this non-domain device. Now this it's not domain joined, it's this new type of object in 2012 R2 and MSDS device. But it's now kind of a known device. It can be used as part of multi-factor authentication, something I have. So now, let's go exactly back to that same site again. It's still going to prompt me the first time. Because this is going through that initial, who are you, creating the token. But notice now I actually have some device claims as well, because it's a workplace join machine. But if I close that and go back to it again, I now have single sign-on. It's not prompting me anymore. Also, as part of accessing some corporate app, you could say, well, are you workplace joined? And only if I'm workplace joined does it allow me to access that. So that's actually a really cool feature. Now, initially back to this iOS device, I can do the same thing. So if I jump to my web browser, and rather than type it in, I've got my workplace join, and it's going to that same site. And you have to log in with your domain credentials. So I would actually do that. So I've typed that in, sign in. It's now going to install a profile onto this iOS device, which makes this device workplace joined. So it wants my passcode. And it's now generating this and installing it in as another workplace join machine. And what I'll also see once it's enrolling, installing the profile. Great. And I have that single sign-on here as well. And, again, something you think you'd probably never see. In my Active Directory, what I should now see is another device. And this is now that iOS device. So I actually have an iOS device now has an object in Active Directory. It's now workplace joined. So this device will be able to get that sort of secure access to my corporate applications if I wanted as well. And again, you can remove it. So you go into the settings, sort of the general, and you have your various profiles in here. So if you wanted to leave the workplace join, I would just hit remove. So then it will no longer be known. So you'll notice there's a lot of things about it. Bring your own device in here. I mean, the new RDP client, not just for Windows. Workplace join, work folders will be available for iOS as well. Really extending the reach of these technologies. So put work folders and workplace join together. That's a great experience for non-corporate assets. And then we get into number 8, web application proxy. So this provides a method to publish services on your internal servers externally. So I can publish things to the internet in a secure way. So you can think of this like a reverse proxy service. And it's also a proxy for ADFS. So ADFS is this federation service, lets me create these SAML tokens. And web application proxy and ADFS are best friends. Web application proxy requires ADFS because it's not just acting as publishing stuff to the internet. I can actually use this to do pre-authentication. So I can say, look, only let things through, only let things go and communicate and get to that backend service if it's already authenticated with me. And it uses ADFS as a big part of that to give me access to only those selectively published apps. I can do a URL translation. So imagine a service internally is called, I don't know, line of business app, LOB app. Well, I can publish that on the internet as lobapplication.saviltech.net. And it's going to only work for HTTPS for those external. So I'm publishing my custom applications, my line of business apps, ADFS. It can even bridge between my claims and Kerberos. So if I have a non-claims aware application internally, well, I can make it work through web application proxy with a claim. So really clever stuff here. So that's actually the best way to understand really what this is doing. I mean, it's easy to think of it, well, it publishes stuff out to the internet. But it's probably easiest to just see an example of it in action. So I created this little picture. So I can think about normally the user comes through and says, hey, I want to get to one of these IIS boxes. They're offering services. And initially, the web application proxy will give me your claims. Who are you? And it doesn't have any. It doesn't have any tokens. It has no cookies. So it sort of rejects it and it says, well, look, I'm going to redirect you to the ADFS server instead. So it redirects it. It comes back via the proxy because the proxy is an ADFS proxy as well. And then forwards that on to the ADFS server, who goes and looks at information in Active Directory based on policies as well. So it has policies for web application proxy and all these different applications. So from here, it creates like this combined policy that's going to say, well, what sort of authentication does that user have to do? Is it multi-form factor? Do I require that machine to be workplace joined, for example? And it goes back and it says, well, here's the challenge. The user sends through that request again back to the ADFS. It checks things, gets information from Active Directory, and now it actually goes and creates them their token, and it creates them a cookie. Everyone likes cookies. So this flows back. And the way this works is, this is how it does the single sign-on. So that cookie, if the machine is workplace joined, just is a persistent cookie. So now any time this machine tries to connect to something via web application proxy, it uses that cookie and gives it access to the service. If it wasn't workplace joined, this cookie is only for that session. They would get that single sign-on capability. So then he tries again to access the application. So he sends his token, his SAML token, with all his claims, and it forwards it through to the application. The application says, fantastic, and I have access. So that's all happy, good news. Web application proxy is giving me that single sign-on. It's making me pre-auth before it gives me access to the services. It's acting as this ADFS proxy, publishing service out to the internet. But now let's say I wanted to talk to this box instead. So I've got my token, I send it through. I go and talk to this IIS box. Well, this one uses integrated authentication. It has no clue what to do with a SAML token. So it basically says, no idea, 401, don't know what to do with this. Well, web application proxy recognizes 401 means, well, it uses integrated authentication and cannot use the token. So what Web Application Proxy does, it goes and talks to Active Directory, uses Kerberos constrained delegation using a UPN from within that token, and just does regular Kerberos, sends it a ticket, and the user is now authenticated and is working great. So this is really showing you the power of Web Application Proxy. It's not just publishing a server out to the internet. It can do pre-auth. It's going to enforce policies about, well, is it workplace joined? It enables single sign-on. It can do that URL sort of translation. So a very, very powerful feature in that work folders, that workplace join, all of those can be published and accessed through Web Application Proxy as well. So bringing all of those different things together. So failover clustering. Big changes again in Windows Server 2012, one-click patching, VM priority, health monitoring, and a lot more stuff. 2012 R2 really enhances this further. I mean, one of the nice things is cluster shared volumes. I might have many cluster shared volumes in my environment. One of the nice things that actually happens in 2012 R2, let's look at my storage and my disks. I have a bunch of cluster shared volumes. And always one node for each CSV is the coordinator node, handles those sort of metadata rights. You'll notice I have 7 CSVs. Well, actually 6 CSVs here. And 3 of them are one node. 3 of them another node. That's not accidental. That's actually a new feature in 2012 R2 that will rebalance the owners of CSVs to balance it throughout the cluster, so they should have an equal number. So just giving me a better performance. Also, if I was actually doing clustered storage spaces and offering an SMB3 for a scale-out file server, it would actually redirect SMB connections to go to the node that is the coordinator node for a particular cluster shared volume, so I get the most efficient path to the storage. It's actually a very nice feature. Shared VHDX is now a feature, and that's kind of a Hyper-V and failover clustering, so I'm going to talk about that a bit more in the Hyper-V section. Relaxed heartbeat mode for Hyper-V clusters. So what's being found is that, I mean, it's not a good thing, but generally Hyper-V clusters are maybe not as well architected from a network perspective as they should be. So by default, clustering every second is actually going to go and try and talk to its neighbors to make sure it's still there. And by default, it can miss up to 5 of those. So if it misses 5 of those heartbeats, it goes into kind of a you're not there anymore and kicks it out of the cluster. With Hyper-V, that may not always be the right thing if your network isn't architected the right way, if maybe you have high latencies, maybe 5 seconds is too short. So in 2012 R2, as soon as failover clustering sees the first VM role added to a cluster, it actually puts it into kind of a relaxed mode. It actually changes that threshold to 10. So if I jump over to here, and if I look at my cluster, if I do a get cluster, and I look at my same subnet threshold, I should see it's 10. Because that happened automatically. If there weren't any VM roles, this would be 5, which is the default. And there's always a balancing act between having it too small and too big. Obviously, the bigger the number, the longer it will take to recognize a node is not available and to do corrective actions. You don't want to make this too big. But if it's too small, what people were finding is sometimes it would kick a node out, which actually didn't have a problem. And you get a bigger outage clustering trying to fix it than actually just what was there by some interruption to networking. So you have this automatic relaxed mode now in Windows 2012 R2 clusters. Virtual machine draining on shutdown. So if I shut down a node in a cluster now, it'll actually give me the option to say, hey, do I want to drain it? Not drown it. So if I pause, I can say drain all the roles. So all the VMs running on this would actually get moved, live migrated to other nodes in the cluster for me. One of the other nice things, so think about virtual machines. If a node fails, they get moved over, brought up to other nodes in the cluster. But what if a node has a network interruption? It loses some network connectivity. One of the things you can now say, if I look at the settings of a virtual machine, as part of my network, I go to my advanced features, I can say protected network. So if this network connection goes down, it will actually be live migrated to another node in the cluster that does have that network available. So instead of having to have the whole node fail, if it just loses maybe its network adapter fails on one type of network. Well, now it would actually go and move that VM to another node in the cluster that does have that network connectivity to keep it up and running, keep it connected. I can actually have an Active Directory detached cluster. Now they still have to be domain joined, but they don't have to create an object in the Active Directory anymore. So if you don't have the rights or permissions to create objects in Active Directory, it can actually work in a detached mode. So it's still AD joined, but I'm not actually creating objects. Witness logic, quorum logic has been changed in 2012 R2, so it will use a witness when it needs it automatically. When it doesn't need it, it won't count it. If you got this 50-50 split, which in the past would kind of result in no one making quorum, clustering will now make one partition have quorum and carry on functioning. So it's got this different split handling functionality. So great stuff in clustering. And then finally, Hyper-V. And 2012 delivered a fantastic hypervisor. I mean, 64 virtual CPU VMs with a terabyte of RAM, numeral-aware, 64 terabyte VHDX, network virtualization, virtual fiber channel, Hyper-V replica, shared nothing live migration, huge, powerful technologies. Getting even better in R2. So live migration could have a shared nothing, it would copy the storage, the memory, the device state over the network. And it was a great technology, worked very, very well. It's got even better in 2012 R2. If I now look at the settings of a Hyper-V server for that live migration, so I go to my advanced features, by default now it uses compression. So whereas in the past maybe it took 60 seconds for a VM, with compression it maybe takes 15 seconds to move that same VM. Now this is using processor resources to compress and decompress the memory, but it uses a lot less network bandwidth, so that means it's going to be much quicker. Additionally, if I have RDMA capable network adapters, I can say use SMB. And then it's going to leverage SMB Direct, which uses RDMA. Now it's going to be a little bit quicker than compression, but the big deal is it's not going to use any processor. It's not using compression. It's just leveraging the RDMA capability of the network adapters, which means it's going to be really, really fast, quicker even than compression, but using basically no processor. So if you have RDMA capable NICs, use SMB. If you don't have RDMA capable NICs, don't use SMB, just leverage the compression option. So basically I get faster live migrations. Hyper-V Replica has also gone through an upgrade. So again, in Windows Server 2012, Hyper-V Replica would replicate every 5 minutes. Well, now I actually have a few more options. So the first one is, if I look at the settings, and I go to my replication, I can now do 5 minutes, 30 seconds, or 15 minutes. So I have different options for the granularity of how often it sends those changes over the Hyper-V Replica. Another really cool thing I can do now is extended replication. So I have my primary VM. I have the replica of that VM. Now I can create a replica of the replica. I can say extend replication and point it to a third Hyper-V server. Now I cannot create an additional replica from the primary. I can only create an extended replica of the replica virtual machine. And that can have its own timings. So maybe from the primary to the replica, it may replicate every 30 seconds. And then from the replica to the extended replica every 15 minutes. So I have great flexibility in how I actually now do that replication. There's a bunch of other stuff. So Generation 2 virtual machines. enabling UEFI, removing a lot of that legacy hardware. So if you think about IDE controllers and legacy network adapters and all this emulated hardware, it's all gone. A Generation 2 virtual machine see UEFI, which means it can do secure boot. And it can actually boot from the SCSI controller. It can boot from the synthetic network adapter. You don't need legacy. In fact, you can't have legacy. There is no IDE controller. There is no legacy ID. There is no legacy network adapter. So this actually over here, if I run MSInfo 32, you see it's a UEFI. This is a VM. It's a Generation 2 virtual machine. If I look at my device manager, I see, for example, my network adapter is a Hyper-V network adapter, and my storage, sorry, not software, my storage controller is only the Hyper-V SCSI. There is no IDE, so it's actually booting from the SCSI controller. And there's a bunch of system devices, but this is a lot smaller footprint. So if I actually go into Hyper-V and look at an example of a Gen 2, so if I look at my settings, you notice there is no option to add an IDE or legacy. There is no IDE controller here. There's no PS2 keyboard or PS2 mouse. Compare that to a non-Gen 2. There's IDE controllers, there's COM1, there's COM2, there's diskettes, just a bunch of extra stuff, which really, I don't need an operating system that's enlightened. It knows it's virtualized. So really, Gen 2 is what you want to get to for your new operating system. So it's only Windows Server 2012 and 2012 R2, 64-bit only. You cannot really convert a Gen 1 to a Gen 2 VM. And there's not really so much a problem with Hyper-V. It's that, a UEFI, which is what a Gen 2 is, it boots from a FAT32. It has a different partition layout. Whereas your BIOS-based machines, Windows, are booting from an NTFS. I can't just convert a Gen 1 to a Gen 2. You'd have to kind of capture back up the OS, lay it down to a new one, and it's really not worth it. There isn't really any huge performance improvement in a Gen 2 over Gen 1 once it's up and running. Now you can install the OS faster, it's going to boot faster. But once it's up and running, you're not going to see any kind of real performance difference between them. So there's no compelling event to try and convert your Gen 1s to a Gen 2. Just for your new machines though, definitely go ahead and use Gen 2 where you can. Shared VHDX. So rather than having to use maybe iSCSI or Virtual Fiber Channel, I can now just take a VHDX file and share it between multiple virtual machines. This is only on the SCSI controller, and it's only VHDX, and that VHDX file has to sit on a cluster shared volume or a scan-out file server, which itself is using CSV behind the scenes. And that's because CSV is actually where it's housing the driver to support a sharing of a VHDX file. But this is fantastic if you're a hoster, for example, because now what I can do is, instead of having to give my clients direct access, for example, to my underlying storage fabric, which I have to do via SCSI or other things, I'm trying to find my cluster. There we go. So I have two VMs, Fiber Channel 01 and Fiber Cluster 0102. I have this shared VHDX file. In the advanced, you can see I've checked the enable virtual hard disk sharing. Also, on my second guest cluster, has the same file. It's also set to shared. So then within that virtual machine, if I actually open up one of these, make it very small again, it's actually going to see that as shared storage. Let me log on. So from here, I could go and launch Failover Cluster Manager. Now, this is actually a great demonstration because this cluster environment uses all three types of storage. So this has an iSCSI connection for one disk. It uses Virtual Fiber Channel for one disk and uses shared VHDX for one of the drives. So when we actually see the storage of this VM, I use this to demo all of the technologies. I'll see 3 shared drives. And what we can actually see is this cluster disk, is my virtual fiber channel, it's 50 gigs. This one is my iSCSI, and this one is my shared VHDX, which is a 25 gig drive. And if I go and jump on the file system and look at all my cluster shared volumes, I have a shared, there's that single file, which is a 25 gig VHDX. So that's just visible inside the virtual machine as if it was shared SAS. It just thinks it's a shared storage drive, but the reality is it is actually just a VHDX file. Now on the host itself, you can actually go and look at these things. So let's just come out this for a second. So if I do my get VM hard disk drive, and we'll look at the first one, and I can say just show me the VM name, the path, the controller type, and does it support persistent reservations? Persistent reservations. And I'll format that auto. Notice the shared one is true. And this really says, was it a shared VHDX file? And you'll see the path of that. If I look at that second virtual machine, it's exactly the same file. So those two VMs are using the same VHDX file. It's shared between them. So really opening up new guest clustering scenarios to you. I can do dynamic VHDX resize. Again, it has to be connected to the SCSI controller. Has to be a VHDX file. But I can now resize storage. So let's look at this VM. This is just a Windows 8.1. And if I look at what disk space I have right now, I can see I have basically a 50 gig drive. What I can actually do is on my Hyper-V box for that machine, I can do edit disk. I select the disk of that virtual machine. Now remember, the VM is running. I'm going to say I want to make it bigger. I'm going to make it 60 gigs. Finish. If I jump back to that virtual machine, it's there. And then I could extend this volume to use that additional space. I can also shrink a disk. So exactly the same operation. Any space that is unpartitioned, it'll actually let me shrink the disk back down. So I select the same disk again. This time I notice I have a shrink option because it can see there's unpartitioned space. So maybe I'll shrink it by 4 gigs. And if again I jump into that virtual machine and it refreshes once it does a rescan. Oh, there we go, it changed. It now sees it shrunk. So again, within the OS, I then have to go and expand volumes, create new volumes, but I can now change these VHDX files without having to shut down the VM. I can do storage quality of service and actually resource metering. So if I look at one of these machines, I can right click on my settings. For the disk, I can expand it out, and under advanced features, I can say limit it to 500 IOPS, for example. I can put in a minimum number to say, well, look, if it gets less than this number, alert me. Then it writes something to WMI and it creates an event log. So it will log this information as part of resource metering as well. So much better storage insight. I have automatic virtual machine activation. So if I'm running a virtual machine that's running Windows Server 2012 R2, any version, and it's running on a host that's running Windows Server 2012 R2 data center that's been activated, the VM will automatically activate. There's actually nothing special you need to do. All you do is in the virtual machine for the product key, you specify the AVMA key, which Microsoft published. That's generic throughout the world. If you use the AVMA key, then it will look for the activation status of the host. And if the host is activated, it's activated. We have a new enhanced session mode. And this is actually leveraging some of the RDP connectivity. So if I jump over here to one of my Hyper-V boxes, and you actually saw this already, you'll notice when I connected, it actually said, well, what resolution do you want? Because I've got this enhanced session mode option. So if I go to my Hyper-V settings, you can see enhanced session mode is set to use if available. So I double click on it, and it's saying, what size screen do you want? I have other options such as saving this for future purposes. What resources do you want available? And the huge thing this enables me to do, which I could never do in the past, I can now do easy cut and paste. Oh, wrong username. Administrator. So let's say I have Notepad running externally. Test, test, test. And I cut and paste that. I can now paste. That's handy there. I can even cut and paste files. So if there is some basic file over here on this machine, maybe in my documents I have something. Sure. Copy this file. I can now paste entire files. And this is only thanks to this new enhanced session mode that's available in 2012 R2, and it's actually leveraging part of the RDP stack within the virtual machine. So better integration between the host and the virtual machine. Again, that's going to become very useful when I think about giving access. Again, if I'm a hoster, clients don't want to RDP to the box. They want to be able to easily connect just from kind of like the host level, not using RDP directly. There's virtual receive side scaling, which enables me inside virtual machines that have very high bandwidth connections to leverage multiple CPUs to handle that. I can do live cloning, live checkpoint export. So now I can actually export out a VM while it's still running to basically let me clone it. There's improvements to Linux for dynamic memory, file consistent live backup capability. So really a lot of good enhancements in the Hyper-V space. And there's more. These are just some of the main ones. And you really need System Center 2012 R2. I mean, I'm not going to go into the detail. I've done this before in my sort of 2012 top 10. You need System Center. If you want to really get the most out of Windows Server 2012 R2, you need System Center 2012 R2. And from a hybrid cloud scenario, Windows Azure. I mean, Windows Azure currently runs Windows Server 2012 Hyper-V. I can take VMs from on-prem and move them to Windows Azure. I can do storage in Windows Azure. I mean, there's a huge array of great hybrid scenarios and really getting the most out of it. So building on this technology, giving you more options, definitely go and look at Windows Azure. Definitely look at System Center. But hopefully this showed you some of the really cool stuff. And I hope you found this useful. Thank you.